This video is going to take a quick look at a concept borrowed from physics, which is known as the dipole moment. The dipole moment is a vector quantity which is associated with a polar bond. More generally, a dipole moment is associated with any separation of charges. A vector quantity simply means that it has both a size and a direction associated with it. The notation being used here, mu is the symbol that we're going to use for dipole moment. Q is the size of the charges that are separated. So this would be like if we had a partial positive and a partial negative, actually finding how big that charge is in terms of coulombs. And then R will be the distance between the partial positive and partial negative end. And the two implications that I'd like to point out here are the role of Q, the charge, and the role of the distance. So since we're multiplying those two things together, the dipole moment is directly proportional to each. So if we have a larger partial charge, we're going to have a larger dipole moment. The bigger the dipole moment, the more polar the bond is. Also, in terms of the separation or the distance between the charges, well, that's equivalent to the bond length. And so the larger your bond length is, the larger your dipole moment will be, and the more polar your bond will be.